Hey, what's up, Stats? Stirrup here. Sorry I'm not here with you guys today, but at that fun training. So this is page 127. So for the next, for Wednesday, Thursday, Friday, I'll be out. So Wednesday and Thursday, you'll do just going through the videos of these, and on Friday, you have kind of a fun quiz that you get to work on together as a group. All right, so problem number 1 on page 127. They want us to find the observed value. And so we want to find chi-squared. So we have an observed value of 4.2, and we have an expected value of 3.8. And so what we're going to do is we remember from the other day that you had observed minus expected quantity squared all over the expected. So what we're going to do is we're going to say, okay, well, observed is 4.2 minus 3.8, all in quantity squared all over the expected, which is 3.8. That's not the bell for you to leave. All right, so I'm going to go 4.2 minus 3.8 on a calculator. That comes out to 0.4, and then 0.4 squared. So I get to 0.16 over 3.8. And then if I do that divided by 3.8, I'm going to come up with 0.04. So this actually becomes a p-value, or this becomes our chi-squared value. Okay, what does it mean that chi-squared value is 0? Chi-squared value of 0 would mean our observed and our expected values would be the same. So number 2, observed is equal to expected, so the exact same numbers. Then on page, going down a little bit further. So you're talking about Ben & Jerry's ice cream has some flavors. So they have half-baked, which is 15% of their sales. They have Cherry Garcia, which is 12% of their sales. They have chocolate fudge brownie, which is 10% of their sales. They have cookie dough, which is 8% of their sales. And they have fish food, which is 7% of the sales. And then everything else accounts for 48% of their sales. So all of these should add up to be 100%. So they find that you had a random sample of 286 people that showed they bought these particular flavors. So 32, 35, 28, 26, 16, and 149. This is our observed, not our expected. Okay, now in order for us to find the expected, what we have to do is we have to figure out 286 times 15%, or 0.15. So this would be 42.9. And then 12%, 0.112 times 286. That's 34.3. 10%, that's going to be 28.6. 0.08 times 286 is 22.9. 7%, so 0.07 times 286 is 20.0. And then 0.48 times 286, that comes out to 137.3. Okay, so those are, the green are our expected values based on our selection of 286, each of those. So state the null and the alternative. So the null, so this is number 3, the null and the alternative is that our sales are equal to our expected, and then our alternative is sales are not equal to our expected value. And then create a t-table. We got that right there. Okay, so that all takes place. And then we have to find our chi-squared. So our chi-squared value, remember our chi-squared equation is going to be observed minus expected quantity squared over the expected. So if I go through our observed on number 1 is 32 minus our expected being 42.9 quantity squared divided by our expected of 42.9. So this is going to give me 2.8. And then as I go down, my observed is 35 minus 34.3 quantity squared divided by 34.3. So this is going to be 0.01. And then if I do my observed, I go 28 minus 28.6. And if I square that, divided by my expected value of 28.6, we're going to get 0.01 again, and then 8%, so 0.08 times 286. Oh, I take it back. Clear. 0.08. Oh, I don't know what I'm doing. Sorry. I'm going to do my observed of 26 minus 22.9. We're going to square that. So 3.1 squared is 9.61 divided by our expected value of 22.9. So that's going to give me 0.41 or 0.42 rounded up to 2 decimal places. Then if I keep going, my observed is 16 minus 20.0. Square that, that's 16. 16 divided by my expected of 20. That's going to come out to 0.8. And then my last category, I'm going to do my observed of 149 minus my 137.3. I'm going to square that. That gives me 136.89, and I divide that by my expected of 137.3. So that comes out to 0.99. All right, so those are that. Now what you should do is you should add up all those things. So that'll give you your chi-squared. So 2.8 plus 0.01 plus 0.01 plus 0.42 plus 0.8 plus 0.99. So that's going to give me 5.03. That's my chi-squared sum. Okay, so that takes care of 3 and 4. All right, then we're going to move on to page 128. It says a die manufacturer tests to see if the dice they make show equal distributions of 1, 2, 3, 4, 5, 6. They roll 1,000 times and the raw counts. So your die, you got 1, 2, 3, 4, 5, 6. That's what happens on a 6-sided die. You would expect to roll 166.7 all the way down, because you should have an equal chance of any of these taking place. And this is going to happen is if I had my sample of 1,000 rolls. What I did is I did 1/6 of 1,000. So I did 1/6 of 1,000 to get those expected values. And then my observed values, I got 158, 170, 164, 154, 178, and 176. So remember, my chi-squared test is going to be this. It's going to be observed minus expected quantity squared over the expected. So if I want to find my chi-squared, I could easily do that. So I'm going to go observed. So I'm going to go 158 minus 166.7. I'm going to square that. So that gets 75.69 divided by my expected. So this gives me a 0.45. And then next one is going to be 170 minus the 166.7. Square that. Gives me 10.9 divided by my expected of 166.7. So that's going to give me 0.06. And then for die number, rolling a 3, it's going to be 164 minus 166.7. We square that, get 7.29, and divide that by 166.7. So this is going to give me 0.04. And again, I'm just plugging these into this equation. Okay, I'm doing the math. Next one, 154 minus 166.7. Square that, it gives me 161.29 divided by my expected value of 166.7. So that's going to give me 0.96. Actually, it rounds to 0.97. Sorry. One whole decimal shouldn't make the biggest difference in the world, but we'll take care of it. So 0.97. And then I'm going to go 178 minus 166.7. Square that, gives me 127.69 divided by the 166.7. So this comes out to 0.77. And then 176 minus 166.7. Square that. And then divided by my expected of 166.7. So that gives me 0.51. And then what we should do at that point, so we construct our table. Those are my chi-squared. Just for practice, add them up. So 0.45 plus 0.06 plus 0.04 plus 0.97 plus 0.77 plus 0.51. And so the sum of our chi-squared is 2.8. We'll be using that. Number 7, so that's basically number 6. Our null hypothesis, we didn't do that. So our null hypothesis number 5 is our null is die equal outcomes, and then the die is not equal to outcomes. Our die equals expected. So die equals expected, die is not equal to expected. Number 7, which outcome produced the highest chi-squared value? The highest chi-squared value would be the 4 of 0.97. Okay, in context explain, having the largest chi-squared value means in the outcome. It basically means, that's kind of shocking that 4 had the highest outcome, because you wouldn't expect any of the numbers to be anything higher than what they should have been. Find the total of the chi-squared values. So this is actually number 8. We summed them all up. And which outcome is most likely to occur if the null is true? So we're looking for the smallest. So this is, roll on a 3 is the least likely because it had the smallest chi-squared value, which is number 9. Okay, so that takes care of the homework. Let's go to 7-3 and see how we do. Now, on this one, we will have, on Desmos, we'll be on page 52. Or on Schoology, you can find the Desmos link for the chi-squared test under this week. So it talks about the previous assignment. We observed expected chi-squared values were computed. The sum of the chi-squared values is the measure of the total of the deviation from the null hypothesized expected values. That just means basically your observed minus your expected quantity squared divided by the expected, and that's just how far. So when you have a sample test of 5, your degrees of freedom would be 4. If you had a sample set of 12 situations, your degrees of freedom would be 11. So remember, degrees of freedom is always 1 less than what we have. Okay, so what we wanted to do is, let's say we went back to our cards. So on page 53, so you have A, B, C, D, and E. So we have 5 events. That means our degrees of freedom have to be 4. Okay, 1 less than the events. And this, remember, this was the we had bought 40 boxes of cereal to see if we got all the cards, and we realized we got 11, 7, 6, 9, and 7. The expected, we should have had an equal distribution of all of the cards if they made the same number of cards. And then they already did the math for the chi-squared. They came out to 1.125, 0.125, 0.50, 0.125, and 0.125, Do I have them all? Did I forget any? 1, 2, 3, 4, 5. I was just off. And then the sum of our chi-squared is going to come out to 2.0. Okay, so this is where we can jump in. If you notice they have chi-squared CDF, that's if we're using the graphing calculator. But what I'd like you to do is, oops, let's. I'm going to Firefox right now to get into this, My Cherry Creek. Go into your Desmos. All right, so if we go under courses, you find stat analysis, and make sure you can figure this out on your own. But if you go under April 12th, use this for the chi-squared distribution. Okay, so a few things, like this is going to be all scrambled up. Let's just kind of scramble these all over the place. So this is a preset program that this particular Dr. Ali Everett set up on Desmos to work. So V is our degrees of freedom. So we found our degrees of freedom to be 4, right? Because we had 5 events, cards A, B, C, D. Okay, so we get that. And then our R equals our critical value. So the significance level, we realize that our chi-squared, we go back here, our chi-squared summed up to 2.0. So what I'm going to do is I'm going to bring this down to 2.0. And this is our chi-squared distribution based on this. So notice it comes up to 0.74. Okay. If you look in the book, they got 0.735. That's fine. We are right there with 0.74. So recall that if P is less than alpha, we reject the null. Okay. This one, we didn't really have an alpha value, but usually we go with 0.05, or if we had a P value of less than 0.05. So if we have a value that is less than 0.05, and it looks like on ours, we come up with this 0.74. So 0.74 is larger than 0.05. So that means we would, in this case, we would have to fail to reject our null because we didn't find strong evidence that between the 5 cards, the probability in obtaining them in any given box of frosted sugar bombs. Okay, so if this value here was like below 0.05, we would reject our null, but in this case, we have to accept it. And basically, our null in this one would have been, we would have had the same number of cards that would have been found. So that's what we're going to run through. Okay, I think I've done enough for you guys for today. Today would be Wednesday, so we have a shorter period. But would you do me a favor and just next couple of minutes, why don't you take a look at page 129 and 130 and see if you can't figure it out. I will have the video for tomorrow that will run through it for you, and I'll mark off these assignments, so 129 and 130, and then what I assign on Thursday, I will mark that off. So have those for Monday so you can show me. Being I'm working them out, I mean, all you have to do is just copy down the answers and make sure you know how to do it. There'll be a small quiz on Friday. You get to do it as a group, and I hope you have some fun with it. It has to do with my top 5 favorite movies, so figure out the order to put those in and make it work. Please be nice to the sub and take care of one another. Bye-bye.